Hello and welcome to part 7 of Dev Maths and Stats Refresher Course, Lecture 1. So we're looking at dealing with brackets next. If you have an expression like this, which is a quadratic, then I claim that this is exactly the equivalent to the expression 3x minus 2 in brackets times x minus 1 in brackets. These two are exactly equivalent. To prove this or to verify this, if you put any value you like into these, put 5 into each side, you'll get 52. If you put 56 into each of these, you get the same answer. Yeah. So whatever you put in, you'll always get the same answer because they're completely equivalent expressions. Now, sometimes this one is useful, sometimes this one is useful, so you need to be able to convert between the forms in each direction. So first of all, we go from this one to this one because that's more easy. So if we expand that, so here, so what we're doing here is we're multiplying this times this and we're getting this answer. So what I'll do is I'm going to show you one of these by hand, because it's a bit slow, but I think you should at least see that it's possible to do it by hand, and then I'll leave you to do the rest. So 2x plus 1, 4x minus 7. So you start with 2x plus 1 in brackets and 4x minus 7. Now, in algebra, when you have two things together like this, if there's nothing between them, this is assumed it means to multiplied. So this bracket multiplied by this bracket. And the way this is done is that the two brackets mean that everything inside here must multiply everything inside here. And it does not matter which order you do it in. So let me do it in this order, where I'm going to say this times this. So 2x times 4x is 8x squared, because 2 times 4 is 8, x times 8 is x squared. And then I'm going to do this same one times this one. It's multiplying, these are all multiplying. So 2x times negative 7, so that's going to give me 2 times negative 7 is minus 14x. That's that one times that one. Then I might move on to, let's write a different colour, blue perhaps. This one times this one. So that's 1 times 4x, well, that sounds fairly simple. And finally, this one times this one. 1 times minus 7, which is minus 7. Okay, so that's expanded the brackets, that's called. You should also simplify because you can combine these two together. So you have 8x squared minus 14x plus minus 14 plus 4 is minus 10x, and then minus 7. So that's the final answer. So hopefully 8x squared minus 10x minus 7 is the same thing that we'll calculate it. That's a relief. There we are. Okay. So you should be able to do these others. So 6a minus 3 times a minus 9 gives you that. So, oh yes, please ignore this tilde. This is because I told previously it was assuming that a is greater than 0. So that's from the previous part on logs. You can ignore that. This one, expand 5 times v times 3v plus 5. It won't give you the answer. I've done this because I was trying to encourage you to think about what the answer should be. You have to change that to a semicolon, then it will print the answer. So check that you can do these before I press that. So if you have not done the next one, then please pause and do it, and then I'll press the answer. So the answer to this one is and then please try the next one, and the answer to this one is, again I didn't do that, it's that. Okay, so you should be able to work out all these by hand. Okay, that's the clue on changing the colons, the semicolons, the colons, semicolons. So if you want to get more practice, it's very easy to change these, just to change these equations to get as much practice as you want. Actually, edit, remove output now. It's now been put on the evaluate menu on the latest version of Maple. Notice before we move on that this one here, 4p plus 7 times 4p plus 7, the two brackets are the same. So you could also write it like this. That's called a perfect square. We'll look at some more of those in a while. Okay, so that's how to get from this form to this form. Going from this form to the other way, that's slightly harder. That's called factorising. Not quite so easy. It's a matter of practice. So for example, to get from 8x squared plus 8x plus 12, that will factorise into this form here. I think I will show you, I will write this one out by hand now on the whiteboard. So this is, while I'm doing this, please remember that at any stage you can just fast forward through these things if you find that it's much too easy for you. It's just so I get the right equation. So we're starting here with 4x squared plus 13x plus 3. So what's put into brackets? So when you're doing this, just be bold and write down the two brackets. And then you have to just look at the possibilities for this. Because we know we want to get this 4x squared and this 3 here. I think in this one, because there's only one way to get 3, which you can have a 3 and a 1. Yeah, so 3, it could be 1 times 3 or 3 times 1. So this 3 times 1 gives you 3. There's no other way of doing it. Then here and here I could have 2x and 2x or 4x and 1x. But I want to get to 13x. So if I have a 2x here, I could try 2x like this. So that will give you 4x squared, but I don't think we're going to get to 13x because when I do this times this will give me 6x, this will give me 8x, so I won't get 13x, so that's not going to work. So what I'll have to do is, instead of that, I'll need to have, oops, if I have a 4 here, and just x here, then 3 times 4 gives you 12, which is getting close, and then 1 times x gives you 1, so that will work. So check this. So this gives you 4x squared, okay. So that times that gives you 4x squared then. This times this gives you 3, that's fine. Then this times this gives you, this times this gives 12x. No, it doesn't. And this times this gives you, gosh. This times this gives you x. This times this gives you 12x. So 12x plus x gives you 13x. So they're all positives, and that gives you the correct answer. So with these others, and let's just check that get the right calculation there. Yeah, good. With these others, just be bold, write out the equation, or write out the expression like this, then write the two brackets and try and fill it in so you get the correct answer, just by a small amount of trial and error. Okay, so before we move on, why bother doing all this? It seems like it takes a lot of time and effort. Well, for example, let's imagine you are looking at the profits of a function, the profits of a company, and the profits of a company are given by this quadratic equation. So pi, which often is stood for profits, is equal to this. And maybe the manager has asked you, as one of the employees, say, what level of output will give us zero profit? Avoid that. So what level of output will give us maximum profit? That's what we want to go for. The answer is, I don't know if I look at this. It's very hard to tell. But if I factorize the profits equation, that gives me some insight. So I factorize this into this form. So there's the original profit function in that form, and then the profit factored form like this. And you should be able to check they're the same, that they are the same now. And then if I plot this and this on the same graph, oh, okay, is that a mistake? I plotted both of those things on the same graph. One should be blue, the other should be orange. Is it a mistake that there's only one line? Okay, the answer is it's not a mistake, because there's only one line, because the values are exactly the same, which just shows that these are identical. So where's the zero profit level of output? Well, it's 4 and 8, so I don't want to produce 4 or 8 because I'll get 0. If I produce less than 4 or more than 8, it's a disaster. I'm making a loss. So 4 and 8 is 0, but the one I really want to know about is maximum profit, and that's at 6. Okay, now what you can do is, using the factorized form, I can do that without needing a graph. If I take this, I can tell that the point where I will get 0 is where Q is 8, because that makes this bracket must be 0 if Q is 8. And to make this bracket 0, Q must be equal to 4, because 28 minus 7 times 4 is 0. So by looking at where each bracket is 0, I can easily find these 2 points just by looking at this one. And then because it's a quadratic, I know that halfway between the 4 and the 8 will be the 0 point. It will be the maximum point 6 here. So from this form, it's easy to tell the zeros, and then from the zeros I can get the maximum in the middle. But from this graph, from this form here, it's very hard to look at this and say where is the 0 and where is the maximum just from looking at that. So that's one quick advantage of knowing it, this form. Okay, in the next short video we'll look at completing the square, but for now, thanks for watching.